G'day, thanks for tuning in. Today we're going to be looking at what's inside this Netgear GS308 network switch. So it's quite a small handy unit, pretty simple. The back of it just has power in, on and off button and a lockable space. So this switch can be locked and chained down somewhere to prevent it from being taken. On the other side it just has 4 feet, really nice rubber, big feet. And then it's got 2 slots in here for mounting. So screws the heads of the screws can come in here, and this can just sort of slide and sit on a wall or something like that. And then the front, we've just got a on light, and then we've got 8 ports. So one of them is used for incoming connection, and the other 7 are then used to split out to outgoing connections. And then up the top left, we've just got a little on or blink for active LEDs there. The case is all metal, nicely made together. There just seems to be 2 screws here, just 2 Phillips heads. So I'll undo them and see what's inside. Okay, so this case here just slides off actually quite nicely. It's just got these little teeth that recess into the other one and slides off. So this is just metal. It would have just been stamped out of a sheet metal and then just bent to form this shape. And likewise with the case, the same sort of deal. So there's a few more screws. I'll undo them and take the PCB out. There you go, so that PCB just slides out quite nicely. The only other thing I guess inside it is just this little plastic caps or stickers on this side with a slight little recess. That'll just be for no dust or anything getting in from this side. Then the PCB itself, not much to it, but we'll start at the power end. So we've got power coming in, 12 volts, half an amp, going through a capacitor just for a bit of filtering. There's 2. So these are going to be little inductors. There's 2 inductors there for more filtering, reducing any sort of current spikes, and just making sure there's a constant supply or a nice smooth supply. This here is just a switch, just a little slide on and off switch. A couple of small little ICs there. So they might be just for voltage regulation because there's this 12 volts coming in. And the PoE protocol, or this isn't actually PoE, but the communications on Ethernet happen between, I think it's 44 and 52 volts, so usually 48 volts. So there'll probably just be some voltage stepping up happening there. We've got a crystal oscillator just here, and right next to it, we've got the actual microprocessor doing most of the stuff, or the actual routing and then the communications. It's got a nice heat sink on it. Depending on how much this is used, this chip could get quite warm, so it's nice to see that extra heat dissipation there. And then we've just got a whole bunch of tracks going from the actual microprocessor over to these guys here, and they're just going to be transformer modules. So these transformer modules, they basically have transformers inside on the TX and RX lines, and what that basically does, it kind of acts as a common mode choke, so any sort of noise, high frequency, especially high frequency noise, it will just filter that out. It'll also just make sure that waveform is a lot more stable for the microcontroller to pick that up, and then the other side as well, whatever it's transmitting to. Because the way this works is that the twisted pair of the Ethernet just uses differential protocol, so same magnitude of voltage on both lines, but the polarities are reversed. So when that comes to the other side, there's some magic that happens inside. So the differential voltage will then just get stepped down by the transformer, so the chip can actually read it. And then just an extra LED on the side here, but that's just for the power LED there. And then we've got these other LEDs on top, as I mentioned before. But that's pretty much all that's it on this side here. There is obviously the underside, and there are actually a few very little small surface mount components, just mostly resistors and so capacitors probably there, just on these lines. But very little on this side, and then just obviously all of the through hole component connections sticking through, and they're actually soldered on there. So thanks very much for watching. Now you've seen the inside of this network switch. If you got a second, hit that like button, and if you do want to see more of this sort of stuff, then consider subscribing to the channel. Awesome, thanks very much, have a good one.